myself Arnab Chatterjee, and today I will discuss about a very important chapter from chemistry class 12 for term 2 examination, and the name of the chapter is coordination compound. First of all, try to understand what are coordination compound. A coordination compound contains a central metal atom or ion surrounded by a number of oppositely charged ions or a neutral molecule. These ions or molecule are bonded to the metal atom or ion by a coordinate bond. Such type of compounds are known as coordination compound. Now here you can see the example of coordination compound. In the given compound, the Fe is the central metal ion, and this Fe is surrounded by negatively charged Cn molecular ion. So this Cn consists of negative charge and known as ligand. Why these are known as ligand? Because these have tendency to donate pairs of electron to the central metal atom or ion to form a coordinate bond. And in the given example, the square bracket part is also known as coordination sphere. I am writing in short, and the rest part is known as ionization sphere. And how many potassium ion present in the ionization sphere? 4. So this 4 will be the counter ion. And how many ligands are attached to the central metal atom or ion? That is 6. It gives the idea about coordination number. And if we try to find out the oxidation state of the central metal atom or ion, then we can find out the oxidation state like this. Potassium carry plus 1 unit positive charge, Fe represented by X, Cn carry 1 unit negative charge. So it will be 1 into 4 plus X plus minus 1 into 6 equal to 0, and the value of oxidation state for Fe will be plus 2, which means in the given complex iron exists as Fe2 plus, known as ferrous iron. It is known as ferrous iron. So I hope that all of you have understood this particular concept. Now, it is important to note that coordination compound do not dissociate into simple ion when dissolved in water. Let's see how it works. If we dissolve the given coordination compound in water, it get ionized like this. So it is dissociated into 4 K plus ion, cation, and the anion consists of the complex part in which the central metal ion is bonded with the ligand. So complex anion is generated, and after dissociation, if we test the solution, we can get the result for the presence of potassium ion, but not get the result of Fe2 plus ion. So this is the very important feature of coordination compound. They do not dissociate into simple ion when dissolved in water, and they do not produce the test of all types of ion present in the given solution of the coordination compound. Now move on to the next topic, double salt. Double salt, simply sounding like this, that it is the combination of two different salts. So you can see that when two salts in stoichiometric ratio are crystallized together form their saturated solution, they are called double salt. Here you can see example of double salt, that is FeSO4. It is a one type of salt. Then NH4 whole 2 SO4. This is another type of salt, and 6 mole of water. This is the example of double salt, and it is better known as more salt. The important feature of double salt is that they dissociated into simple ion when dissolved in water. Let's see how it works. If we dissolve this particular double salt, which is known as more salt, we will get the test of Fe2 plus ion, NH4 plus ion, and also SO4 2 minus ion. So all types of ions present in the given salt can be easily detected in case of double salt. So this is the one of the basic difference between double salt and the coordination compound. Now in this segment we will talk about some of the important terms that are used in coordination complexes. So let us start with the topic coordination entity. What is the meaning of coordination entity? A coordination entity constitutes a central metal atom or ion bonded to a fixed number of ions or molecules. Those are known as ligand, simply represented by the L. So in the given complex, the square bracket part where the central metal ion is bonded with the fixed number of ions or molecules which are known as ligand, known as coordination entity. If you want to identify coordination entity, simply you have to pick the square bracket part of the coordination complex, that is called coordination entity. Let us revise the definition once again. A coordination entity constitutes a central metal atom or ion bounded to a fixed number of ions or molecule. And the trick is that if in any complex, if you want to find out the coordination entity, you have to choose the square bracket part. If you choose the square bracket part, this square bracket part consists of central metal atom or ion bounded to a fixed number of ions or molecules. Those are known as ligand. Now move on to the another topic, central atom or ion. This is very simple definition. In a coordination entity, the atom or ion to which a fixed number of ions or groups of molecule are bonded to a definite geometrical arrangement around it is called central metal atom or ion. So now let us consider this example. In this example, the square bracket part is coordination entity in which iron is present, and if we find out the oxidation state, the oxidation state of iron will be Fe2 plus. So Fe2 plus is known as, this is known as central metal ion. Now I hope that all of you have understood up to this. Now move on to the another very important topic, that is ligand. What are ligands? A molecule, ion or group that is bonded to the metal atom or ion in a complex of coordination compound by a coordinate bond is called ligand. Ligand may be neutral, did not have any charge on it, may be positive or negatively charged. Here are the some examples of ligand. For example, water, Cn and NO plus. In water, oxygen atom consists of two lone pairs electron, although it does not carry any charge on it. So such type of ligand are known as neutral ligand. We do not carry any charge but are electron rich and having tendency to donate the central metal atom or ion. And in the water molecule, oxygen is known as donor atom represented by D. Now similarly, Cn minus, again electron rich species and carry negative charge, so it is known as negative ligand, and NO plus carry positive charge, so it will be positive ligand. Now the next part of this topic, donor atom. As I have stated earlier that the donor atom is the atom of a molecule or molecular ion which consists of extra pair of electron and are capable of donating pairs of electron to the central metal atom or ion. In simple sentence you can write, an atom of the ligand attached directly to the metal atom or ion is called donor atom. For example, in the given example, K4FeCN whole 6, Fe2 plus ion is directly attached with the carbon of Cn minus. So in the given example, carbon is known as the donor atom and its coordination number is 6. So it will show the octahedral structure, OS, octahedral structure. Now the next topic, coordination number. Coordination number simply means the number of donor sites of a molecule or molecular ion around the central metal atom or ion are known as coordination number. So the coordination number of a metal ion in a complex can be defined as number of ligand donor atoms to which the metal is directly bonded through ligand metal coordinate bonding are known as is known as coordination number. So in the given example, there are 6 cyanide molecule and the donor atom is only the carbon, so its coordination number is 6. And as I have stated earlier, in coordination number 6 there will be octahedral structure. Now move on to the next point, and it is coordination sphere. Very simple. The part of the complex in which the central metal atom or ion is attached to the electron donating species known as coordination sphere. So here you can see that this is the coordination sphere because in this part central metal atom Fe2 plus ion is attached to the electron donating species cyanide ion, in which the carbon atom behaving like a donor atom. So I hope that this point is again simply cleared. Now the another topic is counter ion. Counter ion, the ion present outside of the coordination sphere. For example, in the given complex, there are 4 potassium plus ion are present. So K plus is the counter ion. Very simply, we can explain it. And now the next topic, coordination polyhedron. The spatial arrangement of the ligand atom which are directly attached to the central atom or ion define a coordination polyhedron about the central metal atom. The most common coordination polyhedra are octahedral, square planar, and tetrahedral. The complexes having tendency to show either octahedral structure or square planar structure or tetrahedral structure. The structure of the complex can be represented as, for example, if we want to write K4 FeCN whole 6. So this part, the square bracket part, is coordination polyhedron, and this part can be represented like this. CN, CN. Simply we can draw the structure like this. And what is the oxidation state? 2 plus. So this is the coordination polyhedron. Now the some examples of coordination polyhedron are PtCl4 2 minus is square planar, NiCO whole 4 is tetrahedral, and CuNH3 whole 6 3 plus is octahedral. The type of geometry shown by the complexes depends upon the nature of the ligand. That will be discussed in the next segment of the class. And the last part of today's class, charge on the complex ion. The charge on the complex ion is equal to the algebraic sum of the charge on all the ligands coordinated to the central metal atom or ion. This is simply charge on the complex ion. So I hope that up to this level you have understood the concept, and I have tried to explain the all important terminology of the coordination complexes or coordination compound in very simple way. In our next class, we will talk about some more important points of coordination compound. And at last, I would like to say that if you like this particular class, then do consider subscribing for such type of lectures with notes. And thank you for joining me. Once again, I would like to thank all of you for your support and affection regarding my YouTube channel Sunrise Chemistry Plus. Thank you again.